Okay, I'm going to go over the 14.2 notes, and we're going over the transversal and parallel lines today. So this is a picture right here, and basically what a transversal is a line that's going to intersect two other lines. There could be two or more, but these are my two lines, so this one is the one that's intersecting the two lines, so this would be the transversal. Okay, so it's a line that intersects two other lines. Now, if we have parallel lines, if you remember, they're basically lines that don't really touch each other, but it has to be two that, like this would be considered parallel, but you could take this and rotate it like this and it won't actually touch either line in 3D, but that's not considered parallel. So in order for it to be parallel, it has to be on the same flat surface, which we call a plane. Okay? So basically parallel lines, it could be two or more, but I'm going to write two lines that don't intersect, so they don't touch, but they have to be on the same plane, same flat surface in order for that to work. Okay? Let's see if there's something underneath there. All right, now we have a few theorems. There's four of them. And one is called same side interior angles, corresponding, this should be a G right here, corresponding angles theorem, alternate interior angles theorem, and alternate exterior angles theorem. We see these words interior, exterior quite a bit, so I want to make sure you're familiar with that. So before I go on, now we're going to be talking about two lines that are in particularly parallel. So if these were parallel right here, think of interior as in between the two parallel lines. So interior would be all these angles inside. Interior. Inside. And then what we have is on the top and on the bottom, it's not between the two lines. So the top and the bottom are considered exterior. They're outside of the two lines. So these angles are exterior angles. And this back here is the exterior angles. Okay. Now there are special symbols that we're going to be using to show that two lines are parallel to each other. So the shortcut for writing that is, if I have two lines, let's say the lines are M and N, in between here I'm going to use basically two lines that look like they're parallel. That means line M is parallel to line N. So a picture with that would be, if I have two parallel lines, so these lines are just lines. The only thing that it has to have on here to show that they're parallel is an arrow on here. So you could put one arrow, just as long as they have the same number of arrows. So line M on top here is parallel to N on the bottom here with those two arrows, with the arrow on each. If you wanted to, you could put two arrows on each, 2 and 2. Or you could put 3 and 3, just as long as they have the same number. All right, let's go ahead and take a look at these special theorems and postulates. So basically when we have the same side, so they're on the same side, interior. So let's take a look at two parallel lines. Okay, this is going to deal with parallel lines only. So this line right here is parallel to the bottom line, and I'll signify that by putting arrows right here, same number of arrows, and it happens to be cut by a transversal. So it's cut by a transversal. We're talking about interior. So interior angles are the angles that are inside the two lines. So we're talking about not this part and this part, but all these inside angles. And they're on the same side. So it could be on the left side, or it could be on the right side of this. So left side or right side, it doesn't matter. So for this example, I'll put these angle 1 and angle 2. Those are on the same side, inside, same side interior angles. And what's special is if the two lines are parallel, if M is parallel to N, so if this is line M and this is N, If they're parallel to each other, then the measurement of angle 1 plus the measurement of angle 2 actually equals 180 degrees. Another word for 180 degrees is supplementary. All right, corresponding angles theorem. So corresponding angles theorem, we're still starting off with the same concept. We have two lines that are parallel to each other. So in order to show that they're parallel, I'm going to put these arrows. They're cut by a transversal. Okay. And corresponding, think of it as the same exact spot from this cross-section to this cross-section. For example, if I use the angle on the top here as the top left, we're looking at the top left on the bottom, so these two. If I wanted to look at the top right, right here, that would go with the top right on the bottom cross-section. Bottom left, those are corresponding. Bottom right with the bottom right, those are corresponding. So they correspond, same spot from top and bottom. So I'm just going to use this as an example, 1 and 2. These two right here are corresponding. They're exactly the same spot. If I look at that cross-section, it's the top left. If I look at this one, it's the top left. Okay. And what's special about corresponding? I'll go ahead and name these line M and N again. If M is parallel to N, then the measurement of angle 1 is actually equal to the measurement of angle 2. These angles are equal to each other. Okay? And that's only if they are parallel. All right, let's take a look at this next one. Here we have alternate interior angles. Now we talked about interior angles here, but instead of the same side, they're going to be on the alternate sides of each other. So we have two lines that are parallel. They're both cut by this transversal. And when we say alternate interior angles, so we're talking about the inside again, inside the two lines, interior, but alternate sides. Now, when I say alternate, one's on one side and one's on the other, but it's not on the same spot. It's one on top, one on bottom. So like this top, this bottom, or the top right with the, the bottom right with the top left. So these are alternate sides. So in this case, I'm going to write a number 1 and number 2 here. That's one set, but you could use the other set as another set of alternate interior angles. All right, so we'll name this line M and N. So if line M is parallel to line N, then these two angles right here, the measurement of angle 1 is going to equal the measurement of angle 2. Alternate interior angles are actually equal to each other. You can think of this as like a little Z almost. All right, and then the last one of these says alternate exterior angles theorem. So let's draw the two lines that are parallel to each other, cut by a transversal. This time we're talking about exterior, so we're not looking at the middle. We're looking at basically the top skipping down to the bottom. Again, alternate sides. So alternate side of this line. So one's on the left side, the other one has to be on the right on the bottom, not next to each other. Those would be linear pair. On the top and then the bottom alternate. Or you could do the top and the bottom this way. Okay. For this case, I'm going to go ahead and use my alternate interior angles as, let's say, this one and this one. They're on the outside, not in between, and they're on alternate sides of this transversal. One's on the left, one's on the right. So let's name this M and N. So if the measure, or if the line M is parallel to line N, then what's special about these angles? They are also equal. Measurement of angle 1 equals the measurement of angle 2. There's one case that I didn't have on here, and that's the same side exterior. We had same side interior, but we didn't have same side exterior. So same side exterior would be one here and one here. These would be on the same side. Now, if you notice, these angles equal, these angles equal, these angles equal. Basically, all of them equal except the ones that are the same side. If they're on the same side, whether it's interior or exterior, they're going to be supplementary. They're going to add up to 180. Okay? So all of them equal to each other except for the same sides. The same sides are supplementary. All right, let's go ahead and use all these theorems to solve for the angle measures here. Okay? So we know that angle 4 is 70 degrees. So I'm going to go and put 70 degrees next to angle 4. Put it always in the corner. Like if this is the angle, you don't want to write it up here because then it'll be confused. So always put it in the inside part. Okay? So that's 70 degrees. So we can say which other angles are 70 degrees as well. Let's use what we had in yesterday's lesson. If these right here are just two intersecting lines, we have what's called vertical angles. These two are congruent to each other, vertical angles. Okay? Now, if I take this and I slide it down to the bottom, we'll have corresponding angles. See how angle 4 is on the left side bottom? Down here, left side bottom, this is also going to be 70 degrees. Along with the vertical angle across from here, that'd be also 70 degrees. So these are corresponding. Now, how do we get the other angles? The 1, the 3, those will be congruent. And it'll also be congruent to 5 and 7. And the way you do that is you can use the fact that this is a linear pair. Do you remember what a linear pair adds up together to be? These together? That adds up together to be 180 degrees. So to find angle 1, I'll take 180, subtract 70, and that gets you 110 degrees. So this is 110, which means this vertical angle down here is also 110, which means I have to turn on the light. That means down here is also 110. And down here is also 110. So these are all 110 degrees. Okay, let's go ahead and fill out the information here. So angle 1 is 110 degrees. Angle 2 is 70 degrees. Angle 3, right here, that's 110. Angle 5 is 110. Angle 6 is 70. Angle 7 is 110. And angle 8 is 70. Okay. All right, let's see if you can do this one. Try to do this one on your own. And by the way, you can only do what we just did if you see those parallel lines. And the reason why I could do that on this one real quick is that notice I have arrows right here. All right, let's go ahead and go up to this next one. Go ahead and press pause and try this one on your own before I go through it. Okay? Go ahead and press pause. And then when you're ready to go, you can go ahead and unpause and see if you got it right. So I'm going to go ahead and now solve this. So angle 6 was given to us, and that was 61 degrees. So I'm going to go ahead and put the 61 degrees right next to angle 6 here. That's 61 degrees. Because that's 61, I can find all the other 61s. Across from it, that's vertical angles, 61 degrees. If I slide that over to this cross section, notice this 6 will be on top of the 2, the 8 will be on top of the 4, 7 will be on top of 3, 5 will be on top of the 1. Well, 6 is actually going to be right on top of the 2, so that's 61 degrees. That's corresponding. It corresponds. This one also, slide it over, it corresponds. Corresponding angles. Now to get the other angles that are missing there, I'm going to have to use my linear pair. So since I know that any of these, it doesn't matter, I can use this top right here. If I know this is 61 degrees, I can find this side because these add up to 180 degrees. So 180 minus the 61. Remember how to subtract. You'll have to regroup, change that to a 7, and move over this to make it a 10. 10 minus 1 is 9, 7 minus 6 is 1, and then 1 minus 0 is 1. So that's going to be 119 degrees for angle 1. But since that's also vertical pair to here, that's 119 as well. And we can slide this over and say the corresponding angle. So 119 corresponds to this angle, also 119. 119 is here, it corresponds to angle 8. which is also 119. Okay, and you can only do that because it told us that the angle, or sorry, that line M is parallel to line N. These are parallel to each other according to this. If it didn't have that, we wouldn't be able to do it because it could be off by just a little bit. All right, let's go ahead and fill in the information. So we know that angle 1 was 119. Angle 2 is 61 degrees. Angle 3 is also 61 degrees. Angle 4 is 119. Angle 5 is 119. Angle 7, 61. And angle 8, 119. Okay, now let's go ahead and look at this next one. It says, find each value. Explain how to find the values using the postulates, theorems, and algebraic reasoning. Basically, we're going to say same side interior angles, corresponding angles, alternate interior angles, alternate exterior angles. Those theorems and postulates will help us get this. Now, I know there's a lot of lines going on here, so if it helps you, you can kind of darken in some of the lines to help you truly see the two lines. It just happens to be bold right here. So basically we have over here, these are the two parallel lines, road A and B. Those are your parallel lines, and it's cut by this transversal. Okay, so we know this corner is x plus 40. We know this corner is 2x minus 20. And I have to use that information to find what the measurement of angle VTU is. So if I trace VTU, I want this corner angle VTU. Okay, so let's go ahead and solve. Now, what kind of angles are these? Well, these are my two parallel lines. It's either interior or exterior. So this is definitely not interior. I have nothing in between the two lines. What I really have is exterior angles. Now, are they same side or are they alternate sides? Well, if you look at this is above the line, this is below the line, those are alternate. So because of alternate, and I'll abbreviate exterior because they're outside, and I'll abbreviate angles, alternate exterior angles are equal to each other. Remember, the only ones that add up to 180 are same side. These are not same side, these are alternate sides. So what we're going to do with these two are we're going to go ahead and make these equal to each other. So it doesn't matter which side you have on the left, but I usually try to pick the one that has more x's on the left side so we can keep it on the left. 2x minus 22 is going to equal the x plus 40. All right. Now we have to get the x's on one side of the equal sign. So see how we have this 1x here. I'm going to move it over to the other side by subtracting it over. 2x minus x is x, minus 22 equals, and then it's just 40 because this goes away. One step to get x by itself, and that's add 22. So you have x equals 62. Now, it's not asking us to solve for x, it's asking us to solve for what the measurement angle VTU is. So VTU is this angle right here. This is the one that I want. So since this is my angle that I want, I'm going to plug 62 into this right here so I can solve. So I'm going to move that here. 2 times, and we found x to be 62, so I'm plugging in the 62 in for that x, minus 22. Okay? 2 times 62 is 124, and minus 22 gets us 102. So this is going to be 102 degrees. Okay. All right, why don't you go ahead and try this next one on your own. You can press pause and then check to see. Okay. Let's go ahead and do this together, or if you tried it, let's see if you got it right. So roads A and B are parallel. So this is the road that's parallel to each other, okay? And the transversal is this street going across here. All right, what is in my picture? Well, I have nothing interior. What I have are these two, which are exterior angles. Now, exterior angles, are they alternate or are they on the same side? If you look, they're both on the bottom. So since they're both on the bottom, they're on the same side. these are same side exterior because it's outside angles. And whenever we have same side, whether it's exterior or interior, those are the ones that add to 180. See, this is a small angle and that's a big angle. Those are not equal, right? This is a little tiny angle. We call that acute, and we have this big angle, which is called obtuse. They're not equal to each other. What they are supplementary. They add up to 180. So I'm going to go ahead and put that in. So this 9x plus the 22x plus the 25, so that's the 9x, 22 plus 25, that all should equal 180 degrees. They're supplementary. All right, let's add this together. 9x and 22x. They're the same side of the equal sign, so we're just adding like terms. That gets you 31x. Okay, let's go ahead and get that x by itself. So I'm going to subtract the 25. Sorry about all the bells. It's the special testing schedule. So that's 31x. That goes away, and this gets us 155. We're going to divide both sides by 31, and that's going to get us x equals 5. Now, it's not solving for x, it's solving for what angle WUV is. So here's W, here's U, and here's V. So the angle that I'm wishing to solve for is this angle right here. So to solve for that, I'm going to plug in this 5 in here. 22 times x is 5. Plus 25. 22 times 5, that gets us 110. Plus 25 gets us 135. So angle WUV is 135 degrees. All right, and then we have this last one. Because of all the lines that's going on, it could look very difficult to see where the angles that are given. So I'm going to kind of highlight it and point things out. In the diagram of the gate, the horizontal bars, so horizontal bars are the lines that go left and right. Those are horizontal. Are parallel. So this top and this bottom are parallel. And the vertical bars, the vertical are the ones that go up and down, those are also parallel. Find what x and y are. Name the postulate and or theorems that you use to find the values. Okay. Well, let's go ahead and solve for, now we're going to have to solve and find x and y, but in order to do that, we're actually going to have to come up with 2 equations. And these 2 equations have x and y both in it. So I'm going to go ahead and start with the fact that I know that this little angle right here in the corner is 36 degrees. I'm going to kind of highlight the 2 parallel lines. So my 2 parallel lines are here and here. It's cut by a transversal. That's right here. Okay. And do you see this letter Z? When you see the letter Z, that is actually alternate interior angles. The angles are inside, and think of it as the corners of the Z. So this corner of this Z right here is the 36. We're going to be using that along with this corner angle here, and that's this. So the corner angles here are alternate interior angles. That's whenever you see a Z, and the Z could be forwards or backwards, or a letter N. If you look at a letter N this way, that top and that bottom, or if you did this, I guess that still looks like an N. So N's and Z's, forwards and backwards, the little corners of them are alternate interior angles. So those are equal to each other. Remember, they're all equal except for same side. That's not the same side. Same side would add up to 180. So we're going to make these equal each other. We have 3x plus 2y, and that's going to equal the 36. Okay, that's one set. There's my Z. All right, and then the next set you're going to take a look at are these angles right here. We have this angle right here, this corner angle, and this corner angle right here. Now, if I put a little dot there and a little dot here, you'll notice that from the 2 lines, let me grab another color to highlight it. If you look at this line right here, and this line right here, see if you could try to ignore the purple line. So those two straight lines, and maybe if I cover up the purple with my fingers, you can kind of see that where the yellows are. See how this is the very top left of this line, and this is also the top left. Those are corresponding angles because it's the same, the dot is the same where it's placed between the yellow line and the green line. Okay? And since those are considered corresponding angles are actually equal to each other. Remember, it's only same side that add up to 180. So our other equation, in knowing that it's corresponding, and I'll abbreviate corresponding, these are equal to each other where as well. 12x plus 2y actually equals the 126. Okay, now if you don't remember, when you had math last year, you had to use substitution or elimination to get these to solve for. What I'm going to use today is elimination. And in order to use elimination, we want to eliminate either the x or the y. Now if you look at the x, that has a 3x and that's a 12x. In order for these to eliminate, they need to have the same number in front and the opposite sign. So in order for this to eliminate, where I add the two equations together, this has to be 12, kind of pick the bigger number. And this would also have to be 12, but negative. So in order to make this a negative 12, I could multiply everything here by negative 4, because negative 4 times 3 would make the negative 12. But instead of using x, because, I mean, you could, but I'm going to take the easy route. If you take a look at this right here, they both have 2y. The only difference is that they're both positive, and I want them to be opposite signs, so one's positive and one's negative. So that will be a 2, like say minus 2. So that's what I'm going to do. And in order to do that, I have to make this, in order to make this a minus, I can't just simply change the sign. I have to change all the signs of this whole equation. So I'm going to take this whole equation and multiply it by negative 1, and I'm going to write it down here. So 12x times negative 1 is negative 12x. 2y times negative 1 is negative 2y. 126 times negative 1 is negative 126. And from these two, I can go ahead and add those together. And when I add it, I'll be able to get rid of my y's. Because 3x minus 12x gets us a negative 9x. 2y minus 2y, that's 0. 2 minus 2 is 0. It cancels out. 36 minus 126 gets us 90. Oh, sorry, negative 90. And then we're going to take this and divide both sides by negative 9 so I can get x by itself. All right, so we get x equals 10. Negative 90 divided by 9 is positive 10. So we solved for x. But we're not done because we have to still solve for y. So the way you solve for y is you could either pick the first equation or the second equation. Well, I'm kind of leaning towards the first one because those are smaller numbers, but it'll get you the same answer no matter which one you use. So I'm going to use this first one here. 3, and I'm going to plug in the x that I found. X is 10, plus 2y equals 36. So I just wrote this equation replacing x with the value of 10. 3 times 10 is 30. And then I'm going to subtract the 30 to the other side so I can get the y by itself. So we have 2y equals 6. And the last step is to divide by 2. And we have y equals 3. Now, we're not going to write this as a coordinate because it's not looking where the two lines intersect on a coordinate plane. This is just simply solving for what the value of x is and what the value of y is. Okay? And that's it. So your homework is on My HRW, so go ahead and make use of your time and get your homework done in class. I hope you have a great rest of the day.